Hi, everyone. Thanks for joining. My name is Liam Kavanaugh. I'm a program manager in the Azure Cognitive Search engineering team. And I'm here to talk with you a little bit more about how you can leverage Azure Cognitive Search to extend your existing Cosmos database data and provide a really great search experience over that content. But before I do that, what I want to do is give you a little background on what this service is. So just like Cosmos database, this is another one of our platform as a service technologies. The goal of the service is to make it really easy for developers to build a strong search experience over their data. In this case, what we're talking about specifically today is data coming from your Cosmos database. And so just like Cosmos database, also fully managed, we make it very easy to scale. So in our case, what we typically find is when people are searching, there's a couple of different areas of where they might want to be able to scale that. For example, we have consumer sites where they might see millions and millions of search queries, retail, where they need to scale up for events like in Black Friday that we see here in the US, or other events. They might need to be able to scale to handle more content. So it's very easy to scale it up and scale it down as you need to, and then you only pay for the resources that you're using. The other thing that we've done is we've integrated a lot of AI capabilities. And we'll see that throughout today, especially with a new capability that we've added called Semantic Search that I'll introduce at the end of this, that really understand what people are looking for and not just taking a word and seeing if I can find that in the content. It goes far beyond that, even being able to answer questions that might be within your content. Thirdly, because we're a developer platform, we're very customizable. So you can pick and choose whatever you want that user interface to look like. If you want a traditional search experience as you might see in Google or Bing, you can build that. If you want more of a mapping experience where you can search geospatially, you can do that. Because this is backed by API so that you can get the data and then present it in whatever way you want. And then fourthly, we have made a big effort into the area of security and compliance. There are so many different ways that you can secure this environment, because when you're searching data, you need to make sure that data is secured in a very efficient way. And we do that through things like encryption. We actually have double encryption. We support virtual networks and private endpoints. Every single request comes in needs to be authenticated. So multiple layers of security and compliance allows our organizations to bring that content in and feel safe in doing so. So we dig in this a little bit more. Some of the core capabilities that you would see are what you would expect in a search experience. So if you've ever gone to a retail store or done some search experience over an e-commerce catalog, you're probably familiar with a lot of the basic capabilities you would see in search. So for example, as you're typing into that search box, it gives you suggestions. So it goes through your content and says, what are the right terms that I should suggest to that user in that search box? When they see the results, maybe on the left side, there's these categories that allow you to drill down. So if I'm at a retail store and I'm searching for black shoes, maybe I want to drill down on the manufacturer, the price, the size. So we can really quickly look at all of your content and group it so that you can present, there are 10 Nike shoes, 5 Adidas, so that you can click on that, filter it, and narrow it down to it really effectively. And then suggestions, ranking, paging, scoring of search results, all of those things are critical to the environment, the solution, and being able to use geographic is really important in a lot of cases too. Like for example, a customer of ours, Auto Trader Canada, they want to search for cars, but their users search for cars, but don't show me a car that's on the other side of the country. Show me one that's in close proximity. So combining all kinds of different types of data is really critical. So with that, let's jump into an example of what this would look like. I'm going to switch over to my portal here. And so what I have here is just one of my Cosmos database accounts, and I'm going to show you one of the databases that I have, one of the containers, I should say. And so I'm going to open it up. It's just a set of hotels that I'm going to bring in. So if I look at this, I'm going to expand on it here and just click on one of the items here. Here we go. So if we look at one of these items here, if I click on one of them, what you can see here is just a traditional set of JSON content that might describe a hotel. So we have the information on that hotel, we have the address, a little bit more of a complicated JSON with sub-items, a location, remember some of the geospatial items as well. And what I can do here is I can even have like an array of items, so like a set of rooms associated with that hotel. So let's say that we have all kinds of different hotels and all kinds of different rooms stored in our Cosmos database. And let's say that we wanted to actually search over that content. Well, let me now show you how you can extend that to Cognitive Search to do that. So first of all, you could click on Azure Cognitive Search, but instead of doing that, I'm going to switch over to my search service that I have already created. So just like in Cosmos Database, you can create your own service, and you say which region you want it to be into. You get a URL as to where you can programmatically access it. We have all kinds of different scaling capabilities, so you can scale it up, scale it down as you need to. But within your search service, what you have is you have these ideas of indexes. An index is the place where you put your data. It's the thing that you do your searches against so that you can actually get the search results. You can get those categories, those facets I was talking about. So let's go and actually import this data. So you'll see here there's a tool. As I mentioned, I could have just done this through the Cosmos Database portal. But I click on Import Data. And I'm going to choose this samples here because this is the exact same data set. And in case you wanted to try this yourself, you could just choose the samples here and choose hotels. So this is the exact same data set that we were just looking at. And so now that I've chosen this, through our indexing technology, we can crawl very large numbers of data sources. So for example, Cosmos Database, you might have blobs sitting in blob storage, or Azure Data Lake, maybe PDFs, Office documents, even maybe some content in SharePoint that you might want to crawl. We can crawl all those sources, or if you have a data source that's not listed here, you can also just programmatically send the content. Of course, being able to just choose Cosmos Database and connect it to us is really nice because there's no coding. You just let us worry about the changes and we'll bring them in. So the other thing that we've done is we've added in this AI capability so that as you're bringing in the data, you might want to do something to it. So for example, if I go in and add this enrichment, what I can do is I can say, let me choose that text field as to where my main content is, and maybe I might want to do things like, tell me what key phrases are mentioned in there, who are the people that are listed in there, all kinds of extra knowledge that might be sitting within your text we can extract. We can even do language translation. So if you have all kinds of different languages and you want to detect that language and maybe convert it, say, to English or another language, that's built in as well. So it always really does a great job of preparing your content for search. So let me go and actually now customize the target index. So you can see here, we have an index name. We have a unique identifier. I can do suggestions. So I can say which fields do I want to type head suggestions over. I can actually choose what each of these fields do. So hopefully, if you remember, when we were looking at that Cosmos Database hotels, we had addresses, right? And then we also had rooms associated with them. All of them are listed there. And what we do is we say, what can you do with it? Can I filter over a category? Sure. Can I group it or facet it? Can I full text search it? What language is it in, so that we deeply understand that language? So if somebody's searching in French and you have French content, it understands all the unique aspects of that language, the variations. In English, if you're searching for mouse or mice, we understand all those different variations of words. So it makes it much more effective in what you can search over. So let me create the indexer being the thing that will, on a scheduled basis, check for changes in your Cosmos database and only grab those changes and bring them in. And let me submit that. So what it does is it goes out and it creates that index, which is already done. It's going to run the indexer for the first time and starts bringing it in. So now if I click on indexes, we now have this index and I can start querying it. So now all the data is ready. I can go through the developer APIs and start trying it, or I can go to the Search Explorer and just try a few things. So let me get a couple examples. So let's say that I was looking for a hotel that was, well, let's say it's a resort that has swimming and fishing, right? And so you can see here, this is the REST-based API that you would make. Once again, you still have to pass the API key that's listed in the keys section. But if I search for this, let's take a look at this and see what happens. We can see here how it got a result that came back, and it's a resort. So it seems like it's okay. But how did it know swimming and fishing? Like, where was that? Well, let me add in a new parameter called highlight equals the description. And with this, what it'll do is it'll go through and say, I'm going to extract out a couple of snippets that highly represent what you just searched. And you can see here, you can change the tags. But you can imagine in your search results, maybe you want to highlight the word resort or the word, let's see, swim. You'll notice that I typed in swimming, but it still found the variation, which is swim and even fishing, right? So we can actually then present all those results, and we get numerous different search results very, very quickly to show to the user. So now let me make this a little bit more interesting. So I'm going to add in that faceting, and I'm going to say facet, and what I want to do is group over the tags and the category. So if you go down here, let's take a look here. You can see for this particular hotel, these were the tags associated with the hotel. The category is listed as extended stay. So let's do a search, and we can see of the search results that match this text, there are 9 hotels that are listed as having a view. 8 of them have a 24-hour front desk service. And if we go down in categories, we can see here 12 are listed as resort and spa. So how quickly it was able to group that data is a real strength of search engines. And I can even start doing filtering. Like, let's say that I wanted to filter where the category is suite. So I'm going to add that in here and search for that. That is strictly filtering it. So now we've narrowed it down. So a user clicked on suites, narrowed it down. There's only one resort that has free parking, fishing, and swimming. And you can see here we've narrowed it down because we listed only the category of suite. So you hopefully can kind of see how easy it is to navigate over this content. I can even do geospatial. Let's say that I wanted to filter it. Let me just go here and add in a filter. Let me explain what I did there. So I'm filter. I'm going to use our geospatial function. I'm going to search over the location field. As you recall, there is a location field with a latitude and longitude. I'm going to pass the location of the user where they're located. And I want you to send me back search results that match what I searched, but are within 10 kilometers at that location. So let me search on that. And of course, we've narrowed it down to a really good set of results. So all of this comes into play. And one of the great aspects of search engines is how easy it is to adapt to the different types of text and the ways that people search over content. So hopefully that helped as a start. Now what I want to do is introduce you to one of the new capabilities that we've added that goes even far beyond just the types of word search that I've been doing. But before I do that, let me switch back over to my PowerPoint and show you what I was referring to. So if you think of textual search, what I want you to think about is traditional search, or search as it is today. And the way you can think about this is if you look at this image that I have on the left, where somebody said, when did man land on the moon? Search engines today, for the most part, are very what I would call linguistic. It takes those words and it does different variations of that to find which text or which words most closely match that. So remember, I searched for the word swimming and it found swim. That's a variation to the word which did okay. And so if I search for when did man land on moon, you might get a result that says how to buy moon land, because it has the word moon and land. Those are pretty rare, so they're pretty important. Rare meaning that it doesn't happen a lot in the content. So it seems textually to be a good result, but it absolutely did horrible from understanding the intent of what I was looking for. It didn't answer the question of when did man land on the moon. It didn't present me with the right thing. Whereas if you look on the right-hand side, when we add semantic search, all of a sudden we start looking at the context. Oh, this is a question. Oh, here are the types of things. Landing on the moon is what you mean, not buying moon land. So if you can start understanding intent and breaking that apart, then all of a sudden you can drill into even more interesting details. And so if you look at this, there's multiple cool things that came back. First of all, we have this idea of instant answers. Within your content, there might be an answer to a question somebody is trying to ask. So rather than showing them a bunch of documents or rows that come back, why not try to extract out an answer and just present that to them at the top? You can take that query understanding I was mentioning before and start saying, oh, when did man land on the moon? Well, the Apollo 11 was the first one that is most relevant. So we can actually rank that based on what's most interesting. Now, if you look at this in kind of like comparison, let's look at this fine dining places in Switzerland. So today, dining could probably be broken up into the word dine, or fine dine. Switzerland, there's probably no real interesting variation that you could think of for that. Places could be broken down to place. So all of those words might come back as resolved. Whereas when you add semantics, then all of a sudden, fine dining, that might mean 5-star or 4-star. Switzerland might mean Geneva or Zurich. So we can bring in all those together to bring back really great results. And all of this is done using Bing knowledge. So what we did is from Bing, which is crawling the web every day, multiple times a day, and looking at what's happening. It's looking at what people are searching, what they're clicking on, and it builds up this vast level of knowledge, vast amount of data that can be used to provide knowledge from that, to understand semantics and different variations of words and intent, and even handle spelling mistakes so that you can quickly find good results. And if you see here, like in Bing, if you search for delicious Swiss chess, it knows you probably didn't mean chess, you probably meant cheese. So it can adapt to that and automatically present really, really great results. And technically the way this works is through a two-phase approach, where we do the normal searches we just saw a few minutes ago, where I could get really great results. It passes it through our Bing ranker, and it says, let me try to see if I can find the most relevant results of those items you presented. And then we sort it based on that query that they asked and the intent. And that is what gets presented back to the user. And so if we look at this again, and if we actually try using a semantic query, I'm going to show you what it looks like if I don't do it. And let's show it what it looks like with it. And then I'll show you more interesting demos. So I'm going to search. I'm going to say, this time I'm going to search for the words hotel with a gym. And I'm only going to search over the description field. I want you to highlight the words that matched the search query. And I'm only going to show back the hotel name and the description. So let me search that. Now you notice here, it brought back these, and it did find the word hotel, but in the results, you know, fitness was in there, so that was interesting, but it didn't actually detect that fitness might be similar to a gym. So let me change this and add in my semantic search. So there's a few parameters in here that we've added, so let me walk through them all. So first, I'm searching for hotel with a gym. I'm still searching over the description field. I'm still bringing back the hotel name and description. This time, I'm telling it to do a semantic search. So this is going to just automatically apply all that Bing knowledge. I'm going to use the English language as the basis. And I also want you to do spell check so that in case somebody misspelled a word like or put in Swiss chess, it can adapt to that and just change it for me. So if I search for this, now all of a sudden you'll notice how well it did. Like for example, we got some really great results. We got these items here. We got a whole lot of things that mentioned fitness all over the place because it completely understood the intent. You know, gym and fitness center are probably pretty relevant. So this brings back great results. So all of this is nice, but let me show a more complete demo. And so you can feel free to give this a try. This has a bunch of different search indexes that you can use. So all this content has been indexed into a search index, and I can even do things like search over our Microsoft Docs. Microsoft documentation now uses this. So when you search Microsoft Docs, it will use this knowledge to help you present really relevant results. So let me choose this. And you can see I misspelled it as Azure Search. And you notice with traditional search, it didn't do great because what is Azure Databricks? It's not a great answer. But it did that because it didn't understand that this was misspelled. The only interesting word it could find is Azure. What and is are kind of interesting, but not as much as Azure. So you can see why this got the result it did. But let me change this. And I'm going to just add in the spelling. So have Bing go through and say, oh, you probably meant Azure Search. So it adapted to that, changed the search query, and then it brought me back, not bad results. It brought introduction, which is okay. What's new? It's not really that relevant. It talks about cognitive search, so it's a little bit better. So let me get the Bing capabilities to re-rank this. So I just added in the new parameter. And now all of a sudden we have this one, but we also have what is cognitive search. Much more and what's new. So these things went brought down, but the most relevant items came back up in the list. And I can even ask it, okay, that's great. You have some interesting documents, but can you just answer my question? And actually, let me throw in captions so I can highlight it. And we can say, yes. Not only can we send you back the results, the documents, but we can go through the text and we can say, the answer to your question that we found in your content was right here, and present that right back. And all that is coming back in the JSON results so that you can quickly see what you're looking for. So hopefully that gives you a quick look at what cognitive search is, how you can extend all of that content. If you want to learn more about this, you can check out our Azure documentation, or you can check out this page right here, our semantic search overview, if you want to look at some more details on what I just presented on semantic search. I really want to thank you very much for your time. Hope you learned something, and I hope you had a great additional day at the conference. Thanks, everyone.